Wonderful. All right.
Hi, everyone. Thank you so much for joining. If you can please write, if you're in middle school or high school, kind of like I have, in the front of your name, that would be great.
Yeah, you just rename yourself with an MS or an HS and then a dash, then your name. That'll really help us when we do the breakout rooms to make sure we have a good population of everyone.
I don't. Oh, never
And
mind.
if you don't know how to do that, you just right click on your name, or you can right click on your picture and you can hit the word rename. And you should
I have a
be able-
question.
Yes.
So me and Miranda Keithley are on the Zoom together. So does that still count if we're together?
Sure. I think you just can send me an email at staff@stemforher.org with your two names so that we can just take that attendance.
Well, we're just gonna be together for today.
Yeah, I still just send me that just so I have it. So I have a
Okay.
list of who was, because even if you're separate tomorrow, then I'll make note that you both were here today. How about that?
Sure.
All right, anyone else having, it looks like everyone's having a good opportunity of changing their name, which is great. I'll turn it over to Anika there to get us started, if you like.
Yeah, of course. All right. So hi, everyone. Thank you so much for joining today. My name is Anika, and I'll be hosting this week's Gem Hunt. So Gem Hunts are programs launched by Girls Empowered by Math, a student-led organization dedicated to empowering girls to pursue their love for mathematics. At Girls Empowered by Math, we work extensively with STEM for Her, our sponsor, which is a nonprofit organization that has invested over $500,000 to engage more women in STEM. So this week we'll be hearing from 5 different female professionals who extensively use math in their work. Over the week's course, you'll learn about the versatility of math and its vast potentials. And every day, we will listen and interact with a math-based presentation, after which we'll separate into breakout rooms to solve a challenge problem, and we'll join in back as a group and realize the correct solutions and complete our program. You will need your workbook, which you should have received earlier, to be successful in today's program. I like to print it out, but if you want to use it digitally, that's totally fine as well.
We didn't get one.
Didn't get one.
I will put the link in the chat.
Okay, and so also this is an interactive program, so we really ask that you participate to fully benefit from its experience. And that leads us to our few keys of success. It's pretty simple. We ask that you follow basic Zoom etiquette, so that includes keeping your microphone muted while the speaker is presenting and paying full attention. And as mentioned, we need participation. So when breakout rooms are opened, we ask that students discuss the problems with each other. That's really important. And they are challenge problems, so they require collaboration. And finally, please ask questions. This is a program to learn after all, so all questions are welcome and none are stupid. And my final announcement is that before the commencement of today's activity, if you weren't aware, Gem Hunt now comes with the Certificate of Achievement. So you can only receive this if you participate for all 5 days. However, if you can't come for one of the days, you're still eligible for the STEM for Her certificate program, for which you only need to attend 4 days for. But we strongly encourage you that you join the entire week. So finally, let's begin. Today we'll be hearing from Dr. Vaughn-Cooke, who is a mechanical engineer at the University of Maryland, who focuses on modeling, preventing, and mitigating the risks posed by human error. Sorry.
Okay, thank you for the introduction, Anika. I'll just share my screen here. Okay, you can see that?
Yep, I can see it.
All right, great. So as Anika mentioned, I'm going to be talking about human-centered design today. I'm a professor at the University of Maryland in the Department of Mechanical Engineering and also with the Reliability Engineering program. And my particular expertise is in dealing with systems that if a human interacts with it incorrectly or inappropriately, it could potentially lead to some serious consequence, some serious undesirable consequence. And so we're going to talk a lot about that and different implications of that on the system. I think there's some stuff popping up on my presentation. Do you guys see that? Okay, I don't know where that's coming from. I'm not touching anything on my end.
It might be the chat, but I don't see anything.
Okay, all right. Okay, so
I see your mouse. Is it your mouse that's going?
I wasn't touching anything at the time. So
I did see like a red line go. Did you see
yes,
that?
I was hands off at the moment, so I don't know what was going on with that. I teach on Zoom every day, and that one is a first. So
That one is too. This one might be whiteboarding, is what I'm thinking. So let me. I'll turn that off.
yeah, that's interesting. I've never used. Oh no.
Okay, so someone is definitely whiteboarding. So let me figure that out.
Okay.
When someone shares their screen, there's like this annotate button that like in the view options on the top. So some people like click that and then they annotate all over the screen.
Oh, I see.
And then sometimes it tells the name too, like who annotates it.
I didn't know that was an option.
You can erase someone's work.
Like we just
Yeah, if you
erased it
just
for
click
now.
on the thing, you can erase people's stuff that they're writing.
Like, is it gone?
Is it gone on your guys' screen?
It is gone now.
Yeah.
Yeah,
Okay.
like, we erased it.
Yeah.
If you just like click the eraser button when you go to it,
Yeah.
it'll go off.
Okay. I don't see that on my end, although I have several screens over here.
I know.
Okay. All right. So that's deactivated.
I'm trying to figure it out, but yeah.
All right. Well, in the meantime, try to avoid the annotation button. Okay. All right. So as I mentioned, I'm going to be talking about human-centered design today, and specifically how that might apply to different systems. We're going to talk about a bunch of examples. So this presentation is going to be very much example driven. I'm going to give a little bit of background on the research projects we work on in my lab. And then also that's going to give you, it's essentially going to be the precursor to your challenge activity, where you're going to take one of the statistical methods that we use a lot in the research and then apply it to an example of one of the products that we work with a lot in the lab. Okay, so safety critical system. So I mentioned that briefly. What is a safety critical system? Well, as I mentioned, it's a system where if you interact with it incorrectly or in an undesired way, it might lead to, let's say, death or serious injury or any of those types of consequences. So you see here in the upper left corner here, here's some pilots on a plane. That's definitely a safety critical system. Got lots of buttons, lots of screens, lots of different inputs and outputs that have to be made. And if it's incorrectly interacted with, it could potentially lead to failure. And of course, we hear about all the time in the news, plane crashes and other issues related to pilots. So that's definitely a safety critical system. The picture in the middle here, we've got surgeons. Essentially anything in the medical domain, anything in healthcare is considered safety critical. I think it's saying the annotations are coming from this person
writing on the board.
who just has MS in their name.
Yeah, so I would appreciate anyone who's doing that to please stop. I think, you know what, if Doctor, if you could just hit your screen share one more time for me, I think
Okay.
you can disable it if it's
Because it says who's annotating when it annotates, and it's the name MS, but
Right.
there's one person who has just MS.
right.
That's the person who's annotating.
And we need them. It says this should disable the
Oh,
annotation.
disable annotation for
Yes.
others. Okay.
Yep.
All right, and you can erase that.
I can't erase anything on your screen share, but if you maybe can.
I don't know how to do that.
Oh.
Oh, okay, I see.
Maybe stop and reshare oh wait, here's
Okay.
view options. Hold on.
Oh, clear all drawings.
There
Okay.
you go.
I
then-
did hit the annotation, so it should not be doing that anymore.
Now I do see someone else's. How is that? So yeah, so just make sure on your screen share options that you've disabled everything. Like, yeah.
Yeah. Okay.
And is that your mouse moving or is that someone
Yeah,
else?
this is
Okay.
me. This is
Okay, want to make sure. I just
Yeah.
want to make sure we're all good now. Okay,
All
sorry
right.
to interrupt. I'm really sorry about that.
Okay. All right. So so anything in medical systems, any type of anything that doctors have to interact with or patients have to interact with. So these could include medical tools, but these could also include things that the patients have to use outside of the direct supervision of the provider. So any type of medical devices, surgical tools, even things that are used for inputting patient records, right? Those are all considered safety critical. We've heard of lots of errors involving incorrect interaction with, let's say, medical robotic systems, or even interacting with medical record system where wrong names are input. So technology is really important there. In the bottom right side here, we see this is actually a nuclear power plant, right? This is another safety critical system. So anything involving, energy, right? We talked about transportation, medicine, anything involving energy, any type of power-based resource. Those have really, really devastating consequences if something goes wrong. We did have, a partial nuclear meltdown in this country a few years ago at the 3 Mile Island nuclear power plant that actually was traced back to human error. And so this is, this is one of those circumstances where, you want to make sure you anticipate what the needs are of the human user. Lots of buttons, lots of screens, dials, etc. You want to make sure that people are able to respond effectively in these situations. So these are all examples of safety critical systems. And there's two main domains we look at. So one is operator facing technology. So who's an operator? An operator is someone who is trained, meaning that they are employed to perform a certain thing. So examples of those would be like the pilots, the surgeons, the nuclear power plant operators. So they receive training. There's personnel selection, meaning you have to have certain education or certifications in order to work with those systems. So those are what we call operator facing technologies. But then there's also consumer facing technologies, meaning that you can just go around the corner to your local store and you can buy them as a consumer. So a lot of medical devices that patients use, you can find them at your local CVS or Walmart or Walgreens, things that help you test like your blood pressure, etc. Those would be considered consumer facing. Your cell phone, that's a consumer facing technology. You're a consumer, you don't actually have to be trained. You don't need a special degree. You don't have to be hired. Right. So those are considered consumer facing. And the reason why this distinction is important is because if you're not trained, then the risks tend to be higher for something happening that might be unanticipated by the designers. So we're going to talk about both examples here today, about some actual examples where this occurs. So predominantly, we look at what's called the product development process. So from the point of actually conceptualizing idea, so as a designer, you come up with something creative, and then you want to test it before you actually commercialize it and start to sell it, right? And you have to ensure, of course, that it's safe. So, so you have some product. This is actually a blood sugar monitor, also known as a glucometer. This particular product here happens to hook up to your iPhone. So here's a product. Let's say we're developing something like this. The next thing we want to do is figure out who our target population, which in this case would be diabetes patients. Okay, so we want to go into our target population and take out a sample of that population. And then we want to do a few things, right? Because this is prior to us actually trying to sell the product to these individuals or use it for their treatment. We want to try to replicate this device in some form so that we can test it to make sure it's safe. And this is not just safe in terms of being used as a diagnostic tool, but how does the user interact with the buttons? How does the user interact with the screen? Do they understand all of the instructions? So in order to understand that, in order to answer those questions, we want to develop a replica of the devices. So
Yes, Daddy.
yes, someone had a question? No? Okay. If anyone has a question, just let me know at any point.
What's the thing on the bottom of the phone?
On the bottom, so this is the actual, this is a little attachment. So you know where your power cord goes to, your little power plug prong that goes in the bottom of your iPhone. So this has that similar prong, and you plug it in, and then it communicates with an app. And you prick your finger to draw blood, and you put it on this strip that produces like a biochemical reaction, and it'll actually tell you on the iPhone through the app your blood sugar level, which if it's too high or too low, then you're going to have to take some medicine or potentially even go to the emergency room. And so
That's really a cool thing though, so that you don't have to like buy this whole big machine, so that you just have that. That's cool.
it is, although I will say it's a lot more expensive than the ones that you buy at the CVS, which are only like $30. This one is over $100 because it has to communicate with your iPhone, but it has a lot more features to it. So, you know, you are paying a little bit more for it to communicate with your iPhone, which the other ones don't have that. So it's a little bit of a trade-off. These are obviously not for the average consumer. It's for folks who want to spend a little bit more on their glucometer, but they have options like this kind of popping up a lot. Yeah, so so we want to replicate that. There's 3 different ways that we replicate that in the lab. One is through virtual environments. So this device that you see here, this is called a virtual reality cave. I'll talk about this for some of our experiments. It's basically an immersive room. So it's a 10 by 10 3-sided room. You walk into it, you put on your virtual reality glasses, and you can actually immerse yourself in any environment. So we could do things like simulate distraction, like if you were in a really loud or distracted environment, we could simulate that. We could simulate anything that might be going on around you, where, you know, it might not be feasible for you to do that in the real world. Maybe it's unsafe, for example, for you to do that in the real world. So we can simulate that. I'll show you some examples later. We also do a lot of virtual human prototypes. So we can create like an avatar of the human and a 3D model of the product. And then we can do some tests. So what you see here is an example of one of the tests that we've done looking at the different design specifications, like how large you want the casing to be. Like here's my iPhone here. It's a little too large for my hand to grasp comfortably. It would have been nice if someone did a study for me to fit this. but I can't grasp it comfortably. You know, it's a little wide. So what's the best width for someone who has my hand dimensions or people who have similar hand dimensions as me? And so that's an example of a test we might be able to run with virtual replicas of the human population. And then we also do hardware and software prototypes. I'll show you some examples of that, where we actually 3D print different buttons and casings or different product prototypes, and we can test them with the user population. So, so this is how we essentially simulate it. And then the next thing we want to do with that information is to measure how someone will respond when they're interacting with it. So we do that in a variety of ways. So we can use biosensors to test how you're responding, how stressed out you are, what your emotions are, any type of load that you might be feeling. We can test that. And that's as an alternative. So instead of just asking someone, how stressed out were you when you were interacting with this device, we can actually hook them up to biosensors and figure out how stressed they are. And I'll show you some of those tools in a little bit. We also look at ergonomic response, which essentially is how how a particular product is accommodating the user. So how it's fit to the particular needs of the user, like their different body lengths or postures. And then we also look at subjective response. So we can give out surveys to the participants. And the ultimate goal is to be able to predict what a population of users, how they'll respond. We can't necessarily test every single person out there. So we want to be able to predict, again, for a sample, what the particular response is, integrate that into design considerations, and then we circle back through and do this all over again. So we do what's called iterations. So we go back through, we make additional changes, we check to see what the response is, we model it, and keep going through that again as we find new needs of the user. So this is the basic process, and I'll go through some examples here of different experiments we've done. Okay, so I mentioned that we wanted to look at performance outcomes, right? So if you think about like how well someone performs when interacting with a device, there's a few ways that we could actually identify that. So one is accuracy. So how accurate is someone? So what do you want them to do? And what do they actually do, right? That's accuracy. So like when someone grades your test, that's accuracy, essentially. We want to know how well they're actually performing the thing that we want them to perform. So how long does it take them? What's the timing? If you have, let's say, 5 minutes versus 3 minutes versus 3 seconds, that's also important in some cases. Cognitive workload. So we'll talk about this a little bit. This is related to stress. The more stress you're under, the more likely you are to commit some error, to press the wrong button, or to not see when the system tries to get your attention, like a button flashes or something of that sort. And then finally, usability. So you may have heard of this term before. So usability is essentially how the system is meeting the specific needs of the user. Okay, so how usable is it? And a lot of times this is done by rating it on a scale. And so this is something we might ask them a series of questions. So these are some examples of ways that we would actually figure out what the quote unquote performance is, right? That's the outcome that we're looking for. And we'd want to have more accuracy, right? We want you to be more accurate, but we also want you to do it in the least amount of time, with the least amount of cognitive workload and the most amount of usability, right? So these are all things we either want to maximize or minimize. Okay, so here's an example here. So I'm going to play a video for you guys, and I want you to pay close attention to the video because there is going to be a poll question that comes up after this. I want you to think about if you were working in this environment that's in the video, what sorts of things would you be feeling if you were required to work here? Now, the video that I'm going to show you is actually some of you who are local is this group local, or is this okay? So some of you are probably familiar with Washington Hospital Center, which is in DC. It has one of the largest telemetry rooms, and essentially what a telemetry room is. If you have a really large hospital for patients that are high risk, let's say patients who have just got out of surgery, they're considered really high risk, they need more monitoring. You don't necessarily have one nurse for every patient, right? That would be great, but there's just not enough nurses out there for the number of patients we have. So instead of having one nurse for every patient, what they have is these telemetry rooms. And they're essentially these rooms with banks and banks of monitors with what's called telemetry operators. And they sit in front of these screens and they monitor patients, okay? They can monitor, so each of these screens has 16 patients on it, and they have about 4 screens in front of them, okay? 64 patients that one person is monitoring at a time. And they're basically waiting to see if something goes wrong. And if something does go wrong, let's say, the patients are hooked up to all of the various machines, it communicates to the telemetry room if something goes wrong, and the telemetry operator sees that it's concerning, they will actually call the nurses station and say, hey, will you check on this particular patient? We believe that, they're in need of some, additional care. So that's basically how telemetry operators work. Unfortunately, and this is not just the case with this particular hospital, unfortunately, it doesn't always work that way. Sometimes there's signals missed, meaning that an alert comes out that says a patient needs to be checked on, and it's not immediately noticed. Or sometimes there's just a lot going on, right? So that's what I wanted you to see in this video. And then we have a poll question coming up where you're going to be asked about the video, okay? Can you hear that? Okay. All right. Now I'm going to launch a poll here. I think, Anika, I think you might have to launch it. I don't see a poll option here for me. Okay, great.
And launch it. Yep.
Yeah. All right, so the question that you're being asked is, what factors might impact the telemetry operator's response time for a patient alarm? Okay, specifically how long it takes them to respond. Okay, so you saw a video of their work environment, you saw their stations. Which of these factors, and you can select all of them that you think might be relevant, which of these factors might impact their response time? Remember, response time is one of the performance variables or performance outcomes that we talked about previously.
So we've had about 22 respondents so far. 41, 28, 29. 30. 32, so it's still going. People are still probably reading, you know. It looks like they've slowed down. Do you want me to go ahead and show it?
Yeah, and if there's something that you thought about that wasn't on that list, take note of that for a second. I'm going to ask you about that. If there's anyone that thought, you know, I thought of something, but I didn't see it on this list. I'll ask you about that in a moment. Okay, can you see those poll? Can everyone see those poll results? Okay. All right. So so here we have, let's take a look at these. We've got the number of patients being monitored as our top pick. So that's, you know, that's very astute. You know, that's a really important factor. That's actually the amount of patients and the amount, not just the amount of patients, but the amount of things you have to do simultaneously, right? Multitasking, we know that is a really huge, that has a really huge impact on cognitive workload, right? More cognitive workload you have, the more potential you might then have to have compromised performance. So that means you might take longer to respond to something. So that's a really good selection. Lighting in the room or noise distractions, it looks like that was our second pick. There was lots going on. Anyone want to comment specifically on what stood out to you as like the most kind of distracting thing? Go ahead and take yourself off mute. I think Autumn has her hand up.
Yeah, it kind of like, to me, I couldn't really hear it, but it looks like kind of like a party rather than like, oh, like their job, like their, you know, where they're supposed to work.
Right. So yes, there's a lot going on. They're very social. They're talking to each other. You mentioned a party, right? So yes, there's a lot of talking going on. Now myself and my research team, we were there. So there were folks talking, but they're generally very social. You're sitting there doing nothing for hours on end, right? So you're not just going to be staring blankly at your computer. You might be talking to your neighbor or the operator next to you. Avery, you had your hand up.
Yeah, actually, where you stop the picture, that guy isn't even looking at the screen.
Mm-hmm. So they might not potentially be looking at, so the way that the alarms work, there's something that happens on the screen, like some flashing, and then there's like an auditory alert, basically some beeping. So if you're not looking at the screen, you have to rely on what you hear. But as we heard, there's lots of stuff that you can hear. So you might not actually, you might not actually hear it. Did anyone notice that there was many different sounds that were happening? There was a beep beep, and then there was a boop. There were kind of two different tones that were happening. And why that's particularly important is that one of them was a critical alert sound. One of them was saying, hey, look at your screen, something important is going on. And then the other sound was saying that the printer bed is open. The longer boop, that sound was saying that the printer bed is open. And the reason why that was the case is because they opened up every single printer bed for the stations, because every time an alarm went off, it printed out the EKG signal for the patient. You know, those waveforms you see in next to the patient bedside, it printed out that. And so it was just printing out paper constantly. And that was a distraction. So they opened up all the printer beds so it couldn't print, which then posed another problem because now you have these things beeping. And so that was kind of a workaround for just a poor work environment. So that's just an example here of a pretty high risk situation that's, again, not unique to this hospital or not even unique to hospitals in general, right? Any situation where you have information that has to be communicated to someone who has to sit there for hours on end, and they're mostly doing nothing until something requires their action, you can find this in any domain, right? Air traffic controllers who are monitoring the planes coming in, the nuclear power plant operators we talked about, anywhere where you have screens and you're monitoring some system that's predominantly doing stuff on its own until you have to intervene in an emergency. So these are pretty high risk types of scenarios. So with this situation, we wanted to study it further. Now, if we actually went into the hospital and bothered them while they were doing their job, we could actually risk patient lives. So what we decided to do was actually create a replica of this room in our virtual reality cave. So here's the room here. And here's what we created in our cave. So here you see the banks of monitors. We've got some avatars working over here to the side, just like in the room. There's even, you can't see it behind you, that treadmill they had for their breaks, you know, that was up there as well. And essentially we put operators immersed in the environment. We had surround sound, where we actually took recordings from the telemetry room at the hospital and brought them into the virtual reality cave. So you could hear if something was happening behind you or in front of you. And then we hooked up the participants to, this is called a Zephyr Biosensor. It straps around your chest and it measures heart rate and breathing rate and temperature, which are known to be measures of stress and workload. So we can actually see without asking someone in real time, you know, in milliseconds as the simulation is running, how much stress they're under, how much workload they're experiencing. And then we might also ask them after the simulation, when this happened at this point in the simulation, how stressed out were you? And we can look at that compared to all the biosensor data. And we had them similar to the hospital. They interacted with the virtual simulation using what's called a cyber glove. So you can see down here, so they could actually interact with the virtual simulation with their physical cyber glove. So here's another example. So that's one that I mentioned that was for a hospital. But again, this is not unique to hospitals. So this is for, this is a control room similar to the telemetry room for an unmanned aerial vehicle. So basically unmanned planes, which are used quite a bit. This was actually a study funded by the Navy. Again, it's a situation where you don't want to go into the work environment and disturb people while they're doing their work. You want to try to replicate it outside of there. So here's an example that we created for the Navy. And essentially what the Navy wanted to know is what they should invest in for their particular system. They wanted to know, were visual alerts better than auditory alerts? So something flashing versus something beeping that you hear. They also wanted to know tactile alerts. So for example, for some of you who have been in cars that give alerts, if you have a fancy car, sometimes it'll give you alerts by having your seat vibrate. If any of you guys have ever experienced that. That's an example, or even your wristband. You know, if you have a Fitbit or an Apple Watch, when your wristband vibrates, that's called tactile or vibrotactile input. So it's notifying you that something is happening so that you can then look at something else. So they were interested in visual and auditory, tactile feedback. And then they also wanted to know, would voice input, is that better? So instead of it beeping with a fuel low indicator, you might actually have a voice that comes out of the system that says fuel low. So which one is better? Which one actually gets the operator's attention the fastest, helps them respond quickly and accurately? Or maybe a combination of all of them, right? We don't know. We have no evidence, no scientific evidence to say what's the best design here, yet we're deploying these systems and people's lives are depending on them. So part of this study was actually figuring out what's the best combination, which we actually found more is not better. So you can't just load up the user with beeps and pings and buzzes and voices. More is definitely not better from a design perspective. So that was kind of one of the outcomes. And another thing that we looked at was this idea of different types of things that you have to interact with the system. So here you have different types of inputs that you might provide. The basic idea was that something would alert you that it needed attention. You would then direct your attention to it. There's multiple screens, so you'd have to figure out where that sound was coming from, and then direct your attention to that particular screen, figure out what it was asking you to do, determine if it required additional attention. So is it critical or non-critical? Okay, so that's the basic idea. So it would require you to look at something, to hear something, to push a button, to potentially type in information, and then make a decision. Is this critical? You know, do we need to land this and maybe change fuel, right? That's pretty critical, right? Or is it non-critical? So all these different types of activities, which an important thing here with all these activities is that they don't require the same type of cognition, okay? So one of the ways that we looked at this, and we have a few different tools, we have eye tracking glasses so we can see where you're looking when you're looking at it. There's a camera pointed outwards, but there's a camera also pointed inwards that looks at the diameter of your pupils. Okay, so we know that pupil diameter changes as someone gets stressed out. So we can see what you're doing when you're getting stressed out and how you're responding to that by wearing these glasses. And then we have a homemade biosensor that actually my students made in the lab to track, you know, heart rate and breathing rate. And then this vibrotactile bracelet that buzzes every time something happens on the screen, which was hooked into the system. So another example of that, and this is in another Navy project that we're working on, is this idea of mixed reality. So again, you have buttons that you have to press, you have things that you have to read off the screen, and you may even have to touch the screen when you're interacting with it, right? You may have switches, dials, lots of different things that you have to do. And then you also have to respond to information that's being given to you. So again, this is similar to most systems of this type. So why is this important? Why do we care whether you're pressing a button, whether you're hearing or seeing something, whether you're making a decision? Well, that's actually really important, we're finding out. So that's your next poll question. So what type of task is more cognitively complex, meaning is more difficult? Physical task, meaning like pushing, pulling, grasping, that's a physical task. Decision making, these are things like analyzing, making judgment, doing calculations, or sensory, which is like hearing, seeing, feeling. Okay, so which type of task is more cognitively complex or difficult? We can go ahead and launch that poll. All right, so as you guys noted, decision-making tasks are most complex. You had almost 70% with that. So that's that was correct, right? That we know that from a perspective of cognition, that it takes more effort to do what's called higher level cognition. So making judgments, coming to some conclusion, that is going to be more complex than simply pushing a button. That's important as well, but the potential for error is greater with things that are cognitively complex. So we actually want to understand what tasks are being performed fit into these different categories, so we can understand going between pushing a button to making a decision, how that varies. So I'll show you a few more quick examples here of some other experiments that we perform. So we also look at, for these workstations, how you actually, how you set up the workstation influences your performance. So it's not just as simple as putting a monitor in front of you. Like I have, you can't see, but I have several monitors in front of me right now that I have actually set up for my height, and also to make sure that I don't have any neck strain by looking up or having to look to the side. But if I were to go into a control room like the ones we just talked about, there might be a dozen monitors, right? So I would have to do a lot of looking up, a lot of looking over to the side, and it might impact my response time. I might not see something that's in my peripheral vision. So what's the best configuration? That's another question that we're asking right now. Should we put all of the primary information that's relevant right in front of you, or maybe stack it, which might involve more neck strain, but we wouldn't have to look from left to right. So we don't know what's best. We actually, we don't have that evidence yet. So that's another question we're trying to prove scientifically. And here's our last example here. So we're not just looking at specific technology design, we're also sometimes looking at process and instructions design. So if you have a specific process or procedure that you want someone to follow, how do you know that they, or how do you design it in a way to encourage them to follow that process? So this is a company that we worked with that develops masks for CPAP masks, which some of you might have heard of. So folks who have sleep apnea or any type of breathing conditions will wear them when they sleep at night. And they wanted to know if these instructions were designed properly to allow people to size it for their face. So we actually set up in a lab, what you see over here, basically what you would have in a pharmacy when you would walk up to a shelf and you would find a mask on the shelf and figure out what's the best size for you by following the instructions. So do people follow the instructions? Are they written in a way that's understandable? So this is an example of that. And you can actually look at, if you give someone an activity to perform, if you are able to capture their face, to get a video of their face, you could do what's called face emotion recognition. So if you cast a net over someone's face of several thousand points, if these 2 points move from here to here, it's likely that I'm smiling. So I'm experiencing some positive emotion. Positive emotions have a positive impact on performance, in the same way that negative emotions have a negative impact on performance. So if I get frustrated because I can't understand something, that might lead to me having lower performance. Okay. All right, so that was just to give you guys a background for the challenge that you're going to be performing, a little bit of background on some of the things that we do in the lab. So now we're actually going to break into the challenge, which is very much related to what we've been talking about. And specifically, we use several different statistical tools, but the ones we're going to be talking about today is related to regression. So what linear regression looks at is the relationship between 2 or more variables. Okay, so you see this chart over here to the right. Each of these points represents, yes. Does someone have a question? Okay. So each of these points represents a place where, for example, where an instance of X and Y occurred simultaneously. So what we call this in regression, you have an independent variable, which is essentially your predictor, and then you have a dependent variable, which is your outcome. So a really common example is to think of this as like the weather. So you think of predictors, or what are predictors that, for example, is going to rain, right? You might say, well, I see clouds, right? So your predictor could be clouds, and your dependent variable or your outcome could be rain, right? So you want to know the extent to which clouds are a good predictor of rain, or to which it influences, okay? So that's essentially what linear regression does. Now, from the perspective of a population, each of these points here would represent a different individual, okay? And you could look at a factor associated with an individual, and then an outcome, which in this case would be performance, okay? So similar to the weather example, you have some characteristic of an individual, and that would help you predict some outcome, like timing or accuracy, or any of the other things that we talked about previously. Now, where it gets more complex, because it's not just as simple as one predictor and one outcome, you're likely to have multiple predictors, which is called multiple regression. So you have two or more independent variables. So going back to the weather example, it's not just the cloudiness that helps you predict, that helps you predict rain. It might also be the humidity, right? The amount of moisture that's in the air. It might also be the color of the sky, right? You might have several independent variables that help you predict rain. Similarly, from if you're trying to predict what a human might do, there might be several characteristics of the situation or of the device that would help you predict performance. So that's multiple linear regression, also known as multiple regression. And the idea is that you have a population, you're going to take a sample, a representative sample of that population that has the same characteristics of the larger population, and then you're going to use it to predict what will happen in the actual population, plus or minus some error, right? Because predictions are never 100%, right? We can never do 100% prediction. There's always going to be some error. But of course, we want to minimize that by making the best model possible. Some things to consider that I'd like you to consider as part of the challenge. Does the independent variable have a positive relationship with the dependent variable? So if the independent variable increases, does the dependent variable also increase? So again, going back to the weather example, the more cloudy it is, we would expect the likelihood of rain to also increase. That's a positive relationship, okay? That's an example of a positive relationship. And then, for example, clear skies, right? The more clear skies we have, we would expect the likelihood of rain to decrease. That's a negative relationship, okay? So generally, when you're coming up with different factors that might influence an outcome, you want to think of, let's come up with a few positive factors that have relationships that'll help that outcome increase. And maybe there's some negative factors as well. Another thing you want to consider is what's called confounding variables. So again, going back to the weather example, I mentioned maybe cloudy, the amount of cloudiness would influence the likelihood or your ability to predict the likelihood that it would rain. Now, let's say there's other variables that also predict that. If you don't include those variables, you could have a less accurate prediction, okay? So if I don't, for example, include humidity, if I don't include the color of the sky, then those variables will do what we call confound the outcome, because I'm not measuring them, but they are influencing my ability to predict this thing. So it's important to try to include all of the variables that you can think of that will help you to create a more accurate model or prediction of your dependent variable. Okay, So the example we're going to work with here is for patient self-management devices. So I mentioned this a little bit earlier at the beginning of the presentation with specifically with glucometers or the things that test your blood sugar. So there's other devices that fit into this category, and they're called patient self-management devices because the patient uses these devices to manage themselves. So these are not things that you use at the hospital. These are not things you use under the supervision of the doctor. These are things that the patient would use at home. So you may have seen your parents or your grandparents or some adult around you using these devices, or you may even have use of these devices. So up here on the top left, you see this blood sugar monitor for diabetes patients. This over here is a blood pressure monitor. So for anyone who has high blood pressure, who has to test their blood pressure regularly, again, this is a device you use at home. Okay, so their patient self-management. This, some of you may recognize down here if you have asthma or if you know someone who has asthma. This is an inhaler, and this device here actually helps you check the amount of, actually count your doses. And it connects to an app that you have on your phone, and you can also use it to test your lung capacity as well. They have other devices, and so again, these are all things that you use at home. Now, of course, from the perspective of designing devices like these, we want to know, are they designed in the best way to make sure that people are actually using them? If they're not using them, then that might potentially compromise the outcome. So your diabetes or your asthma or your high blood pressure, they might get worse if you're not monitoring your condition. And you may not be using the devices because of a variety of factors, right? And that's kind of what I want you guys to think about here today. So the scenario is that your doctor gives some instructions. Those are noted. That might be to do something X amount of times, or to take this amount, whatever the instructions are that are provided, and then you have to implement those. But of course, many times there's what we call non-adherence. So the doctor says, take 2 of these and call me in the morning. You may not take 2, you may only take 1 or none, or not adhere to whatever the doctor is asking. So why does this happen? Why does non-adherence happen? Which is actually, in terms of improving disease and treatment outcomes, is a really big risk. So what you're going to do in your groups, you're going to answer the questions, what are the predictors or the independent variables for non-adherence to recommended use? You're going to consider things related to the patient. So what are things that if you tell someone to do something that might prevent them from doing it, related to the person who's being told, so the patient. What are some things about the device? Again, not a specific device, but in general, what are some things about a device, if you're interacting with it, that may then lead you to not adhere to what someone is recommending for you in terms of using it. Also, what environment are you using it in? Remember, this is home environment. So what is it about the home or any other environment that might prevent you or demotivate someone from using the device? Also, is there anything about the doctor that might potentially lead to non-adherence? So come up with a list of 10 to 15 independent variables. I want you to discuss the factors in your group and then agree upon a list. And what you're going to do is I'm going to send you a link in the chat. So you're going to enter, one member from your team is going to enter a list of factors that you agree upon in your in this website called polleverywhere.com. And then we'll discuss the outcomes. Okay. So So again, I'll send this to you in the chat. Only one submission per team. And you're going to separate your factors by commas, like you see here, factor 1, comma, factor 2, except they're going to be the actual factor names. And you're going to create a long list of these things that you feel like are relevant. Okay. Any questions before you guys go into your groups? Okay. I'm gonna. All right, I have sent you guys the link. So again, only one person from each group needs to submit that, and you guys can go into your groups now if they're set up.
All right, they are set up. So I will put everyone into a group. All right, we're going to open all rooms. You have 15 minutes in there to work on this. Does that seem about right?
Yeah, 20 was probably an overestimation.
Okay. All right. And copy, or someone just hit that link so you have it open on a separate screen. And then again, make someone sort of your team captain in the breakout room. Once you're in there and you figure out who's all in there, you introduce yourselves. And I know our GEM girls will be in to help monitor as well and help you out. So bear with, and hopefully everyone goes into the room. And if not, I will help you. Okay, so everyone is going in.
You know what? I might have the option now to like move myself. I see a breakout room like the 4 things there
You
now.
see it now, though? Okay.
So there are 6. So Hyun, if you want to do 3, I can do 3.
Oh, which do you want me to take a specific room or?
How about like every 5 minutes we switch?
Oh yeah, I'll rotate then.
Okay, I'll do the first 3 if you want to do the last 3.
Yeah, I'll go from
Yeah,
rooms.
take
to, like,
yeah, take that link and with you just in case, and post it in the chat once you get into the rooms, just to help, just in case someone didn't collect it before they went.
Yep, got it.
Right. Bye.
And of course, I left you out here with me.
Yes. I was making sure that it was activated. Yeah.
Okay.
Yeah, this is the first time I've used this tool.
I've never, yeah, what is the name of it again? It's called a
Poll Everywhere. I've heard folks at the university using it, and we do have an account. And I was looking for something that, because Zoom, of course, is limited. You can't actually put in free form text. So if
I know. Yes. Yeah.
yeah, they're not quite there yet. But this was one of the ones that that I've seen, I just recently started to explore it and ran some tests, but it does a much broader range of things.
Oh,
Yeah,
I've never used it before either.
yeah, one of them is this word cloud activity.
Oh,
And so it kind of throws up everything, and then the size of the word is
it's
basically
based off of what
Yeah.
other people put in.
right. So I tried it a few times and it works. I mean,
Yeah.
barring any technical, there's always technical issues.
There is, isn't there?
What's that?
There is. Okay, someone asked for help already. So let me take this with me.
Okay.
I'll be right back.
Okay.
They want to know what the question is. Select important variables. Like they're like, we kind of forgot the question.
Right. So that maybe I'll put this back up here. What are the predictors for non-adherence?
Okay, let me, I wonder how I can like.
Maybe, well, let me maybe copy this for the whole, because you can send a chat to
Yeah.
the whole group.
Or if I could just, yeah, if I'll just jump in and put it in their chat too.
Okay. Well, this is sending it to everyone, even the groups.
Okay.
Okay, that should have gone out to everyone.
Yeah, do you want me to, I'll go jump in and just check.
Mm-hmm.
So that way I can see if it came in.
Okay.
I will be right back.
Mm-hmm.
I think I can. Maybe I can't. Let me. Oh, I'll be right back.
Mm-hmm.
I'm gonna pause the recording.
Okay.
Okay, good.
Let me trying to like grab this and pull it over to the other. Can you see that?
Yes, I can.
Okay. Okay.
Well, now it looks a little funky, but oh, did they put the numbers too?
I guess, what are the numbers for? These are,
I'm guessing
oh,
they
they,
1, 2.
oh, they listed that. Okay, yeah. Okay. All
I'm
right.
gonna start closing the rooms, okay?
Yeah. Is everyone back from the rooms?
Yep, I think everyone's back.
All right. So guys, thanks for inputting your responses here. So this is essentially what it produces, this word cloud that gives different weights based on how many times the word was used. So of course, the larger words mean that across the groups that you guys talked about it more. So you talked about instructions a lot, which is really important. Of course, if you don't know what you're supposed to do and you're not given clear instructions, you potentially might not actually use the device. Doctor was talked about a lot. Time, which potentially maybe relates to time you have to actually complete it. So that's stuff that patients talk about a lot, is that they don't have enough time or they're too busy And so that's really important. I think I see forgetting up here as well as one of the things related to time. So of course, doctor and patient are going to appear a lot. It looks like also, medication appeared a lot. Unclear, which kind of ties into the instructions, and lots of other words that are kind of on the periphery of these, but it looks like the idea of like instructions, understanding, forgetting, things like that seem to be really pop up to the front, which is I think that's really important because those are the things we typically find for devices of this. So that was a good job, guys, just in kind of brainstorming this. Let me see if I can get rid of this screen. Okay, can you see the slides again? Okay. All right. So the idea with this, of course, is that if you had a list of these variables, right? So you guys came up with a list of variables in your group. These are what you say are the predictors for non-adherence, right? So what do you do with that information? So how do you, as a designer of devices, then take into account those factors? Well, you'd want to then measure those factors in the population for a specific device that you were designing. So that you could specifically identify what factors are important for those devices. So I'll give you some examples just to kind of just to summarize what you would do with this information. So here's a glucometer. This is actually a study we did in our lab where we put on disease simulator glasses for eye disease. So if you have glaucoma or cataracts, or even if you have, you're nearsighted or farsighted, you might not be able to read the information that's on the screen, right? So that's a factor that's important. So we actually set up a study to measure how we would better design a screen based on these eye diseases. In terms of instructions, you saw an example with the sleep apnea mask that I mentioned previously, where you might be able to study those types of factors. Here's another one. Here's the virtual study we looked at in terms of comfort, grasping a handheld device such as a patient self-management device. Here we have prototype devices, and we looked at different factors related to how you would actually interact with it. So these are actually arthritis simulator gloves. So you can build different types of buttons, and then it restricts your movement, similar to how arthritis would. If you know any older individuals who might have might have trouble grasping because of arthritis, this is something that would impact them. Also, we know that that typically some of the individuals using these devices who tend to be older, might not have as much technological skill as some of you younger folks, right? Who are always using phones and iPads and all of that. And so that also becomes an issue as well, and another factor to kind of study. All right, so in conclusion, a few things that we went over today. We talked about predicting how a human user might respond or perform, which is a critical part of design. So anticipating what that need is in advance. We talked about the different ways that you could define human performance. So timing, accuracy, how much workload they have, whether they think it's usable. And it's important to consider all factors, right? So we want to create a comprehensive list of all the things that might influence performance so we can understand what the major factors are. And then we want to integrate this information into human-centered design. So essentially what you guys did in your challenge is you created a list of factors, and based on the weighting of them, you determine which ones you thought were most important, which if you were to look across all the groups, things like instructions and forgetting and things of that sort, we might see those come up as heavily weighted independent variables in a multiple regression model. And we might then want to focus on that. That's an example of how we might want to use this. Okay, so before I end, I did want to advertise our design day. So for any of you whose interest was sparked by this engineering perspective in terms of how to design for individuals, this is actually a course that I teach at the university. It's a mechanical engineering course for senior undergrads. And we have a design day every semester where the students who take the course, they design something of their choice, something that essentially helps the world, and they have to prototype it. And then they have basically an exposition where they present it. So it's usually on campus, but of course, because of COVID, it is virtual, and it's open to the public. So we typically have middle schoolers, high schoolers, lots of folks who attend. You can interact with the students. You can go to their different virtual booths and see what they design, ask them lots of questions. And if you're interested in understanding a bit more how engineers are approaching some of these problems, it's during school hours. And it's not an official school sanctioned activity. So, obviously if, you guys would have to get permission, but it is an educational event, and I'm happy to, if your teacher wants to know why you are asking to miss class for an hour, I'm happy to provide any official promotional material we have from the university. But you're welcome to attend. And this is the link where you can register, and this is Tuesday, May 11th. Okay. All right. So I'm going to end there. Thank you for your participation and for providing your input to the challenge. I hope you found it informative and at least provided a bit more information on human-centered design. If you guys want to read a little bit more about our lab, here's our website. And of course, if you guys have any questions, my email, if you wanted to, well, we're not open now, but we do take visitors to the lab, maybe in fall 2021 we'll be back open, and we always have tours and various things if you guys want to come and visit the virtual reality cave or any of those other fun things once the campus is back open. Okay, any questions before we go?
Just out of curiosity, is there one factor that you found is most effective at, I guess, improving or reducing human error?
Just kind of generally, I think it would be cognitive workload. Obviously different devices have specific needs. I would say broadly across any device, it's, how much stress you're under, how many, how much cognitive burden you have. So we kind of talked about that from the perspective of how complex an activity is.
Mm-hmm.
And so that's something that that always comes into play when you're looking at errors and things of that sort. But yeah, I would say that's probably globally the more important one. But when you look at specific devices, there may be other factors that pop up, like in an example with the patient self-management devices that we were just looking at. There's lots of other factors that are not necessarily cognitive workload that would but are related, like we did find that with the medical devices, how health literate an individual is probably one of the most dominant factors, which kind of relates to what you guys were bringing up in the challenge, which is instructions and things of that sort. So if you don't understand, and that also has to deal with technological skills. That's also probably one of the bigger factors we saw, again, tying into like the big one that you guys identified in the challenge, which was like instructions, right? Like how much support are you giving an individual who is maybe struggling to understand what they're supposed to do and when they're supposed to do it. So it kind of varies based on what setting you're looking at, but there are some factors that tend to be important across the board.
Right. Yeah, I can see that happening. Like during a test, being stressed out definitely is like not something that's good.
Yeah. I mean, if you think about, being, really anxious or anything while you're trying to do some really stressful activity, you're likely to commit more errors or be less accurate with that activity. And so it's definitely, it's definitely something, particularly like with the control room type of experiments, is definitely something that becomes more impactful there.
Yeah, like performance anxiety, test anxiety, all those things.
Yes, you guys have lots of standardized tests you have to take. That definitely, you'd have a lot of the factors that would be similar to the factors that control room operators would have. Distractions are going to, play a huge role there. Any type of anything that is basically causing stress, that's going to play a large role there. Yeah.
Yeah. Okay, well, I don't know if there are any other questions. But if not, I guess that's it.
Okay. All right. Well, great. Good to meet you guys. And
thank you so much for your time. It was really informative. And I mean, I didn't even think about half the stuff that you mentioned. So I'm glad someone's researching it.
yes. All right, great. Well, nice meeting you guys, and enjoy the rest of your challenge events.
Yeah, come to the next one tomorrow.
Hey,
Yeah.
I'm looking forward to an in-person invite. So we hold this event in person in your lab, and we can actually kind of see what you're talking about and actually, have an experience on your campus. We can encourage, girls to think about college opportunities. Yeah.
Yeah, that would definitely be fun if we could get together a group next year. So to do something like that would be great.
Yeah. Wonderful.
Okay.
Is STEM for her considering any like in-person activities in the near future at all?
Good question. There's nothing on the books currently. I know there's a few groups that we work with that are looking to actually this fall have in-person events. As we were just talking about this too, is that as more and more people become vaccinated and things look positive, I think there is encouragement to hold smaller group in-person events. So hopefully, fingers crossed, we will see. Yes, as we all want to get everyone back into school and back in and having all these wonderful experiences on campuses like the University of Maryland, which obviously probably has lots to offer to, show us more too.
So we typically have around this time we have our Maryland Day.
Yeah.
Actually, it comes up this month, and we usually have an open house. And sometimes we shut down. We do a half day open house, and then we shut it down for activities later in the second half of the day, which we've done in the past, like individual tours and groups for that. So that might be an option.
Yeah, I think it would be great.
Like, yeah, to learn about different career paths and stuff.
Yeah.
It would be a good opportunity for high schoolers, I think.
Yeah.
Agreed.
And it's right in line with what we encourage our high schoolers to do too. So definitely I will be in touch.
Okay, great. All right. Well, good luck with the rest of the events, and
Thank you.
And I will we'll be in touch.
Wonderful.
Okay. All right.
Thanks all.
Bye, everyone.